Okay, so this video is meant to go through the concept of electrostatic force. And reminder that electrostatic force is a field force. So it occurs when you have a charged object that is in another object's electric field, okay? The symbol for it is pretty easy, it's just Fe. The equation for it is Fe equals EQ, okay? So let's kind of go over what those, oh, I lost my board. Let's go over what these are. I'm just trying to make it not so wobbly. Q is just a charged particle experiencing a force. And then E is the net external electric field that the object is in. And it's a force, so the units are just newtons. Okay. Now, it helps to kind of look at this equation through the lens of what electric field is. Okay, so if we start off here and say that Fe equals EQ, remember that E is just KQ over R squared. But now we need to be specific because we're saying I've got a charged particle and I have some other external electric field. So I'm going to rewrite this and say that Fe is an external electric field. So I'm going to call it E2 acting on charge 1. So if it's E2, then this would be specifically KQ2 over R squared. And I can take this and plug it in right there. So this would become Fe equals K Q2 over R squared times Q1. And oftentimes this is just rearranged to be Fe equals K Q1 Q2 over R squared. This equation is pretty important in the study of electrostatics. This is actually called Coulomb's law. And an important thing to note is that electrostatic force is an action-reaction force. It's a mutual force with just two objects interacting with each other and exerting that force on each other. So if you were to kind of diagram it out, like let's say I have a particle 1, it's positive, I'll call that Q1, particle 2, that's Q2. So they both have electric fields, like those electric fields are going outwards from each other, and they're going to repel each other. Like they're positive charges, they're like charges, they're going to repel each other. So there's going to be this force on particle 1 due to particle 2, and there's going to be a force here on particle 2 due to particle 1. So if I think about this, right, this F12 would be equal to the electric field from particle 2 times Q1, which mathematically comes out to be, and then over here, this would be F21, this would be the electric field of particle 1 acting on Q2. So this would become and they're the exact same. Like if you look at the products, they're the exact same. So electrostatic force is a mutual force. It's very similar to the gravitational force, both in its nature and the mathematical model. They're just in opposite directions, okay? So we'll go through and look at some examples of electrostatic force, but then also look at what happens when you have more than two objects and you have a net electrostatic force acting on an object.